Determine the perimeter and area of each rectangle. To find the perimeter, we add up all the side lengths. If we add 1/4 and 3/4, that gives us one whole. So I have 3 plus a whole makes 4, plus another whole makes 5. So these two sides combined make 5, and these two sides combined make 5. So our perimeter here would be 10 centimeters. To find the area, we multiply the base and the height together. It's going to be easier if we change them to improper fractions. So 1 times 4 is 4, plus 1 more makes 5. 3 times 4 is 12, plus 3 is 15. 5 times 15 would be 75. 4 times 4 is 16. And area uses units squared, so centimeters squared. In each figure, the line segments make up a portion of a capital letter in the English alphabet. Each letter is symmetric about the x-axis and the y-axis, or both axes. Sketch the segments that complete each capital letter. You can see in this first one, it isn't symmetric over the x-axis, but it can be symmetric over the y-axis. So we're going to sketch symmetric, meaning that it's the same on both sides. This one here, we have a line and a piece going here, so it is symmetric over the x-axis because it's 3 away from the x-axis here and 3 away from the x-axis here. And we can finish this by reflecting it over the y-axis. So it's 2 across, and then it goes 3 up and 3 down, creating the letter H. Here I have a piece like this. So it's reflected over the y-axis, so you can see it goes 1 to the left and 1 to the right. And then we can also flip it over the x-axis. It went 3 up, so we need to go 3 down. It went 1 left and 1 right, creating the letter I. On this one, you can tell it's not reflected over the y-axis, otherwise we'd have that line segment here. And we have 1 here and 2 there, so it's not symmetric across the y-axis. This one goes 3 up, so if we create one going 3 down, and then from there, it goes 3 to the right, so we can create that line 3 to the right. And there's also this line that's on the y-axis, which creates the letter E. It's hard to see the ones that are on the axis. On page 215 in your book, there is a coordinate plane that you can use to help answer the following questions. Question 2 says, identify the ordered pairs of the endpoints of a vertical line segment with a length of 3 units. A vertical line segment goes up and down, and we need it to be 3 units long. You can either keep it in the same quadrant or you can cross over into a different quadrant. We talked yesterday, or in the previous lesson, about how if it's in a different quadrant, you would add the absolute values, but if it's in the same quadrant, we could subtract the absolute values. So we have 3 units long. So it needs to be 1, 2, 3, and vertical being up and down. Now we need to identify the coordinates of those two endpoints. So we go from the origin, right 1, 2, 3, 4, 5, 6, 7, 8. And for the first one, we went up 1, 2, 3, 4, 5. And for the second one, 6, 7, 8. So they have these in common, the x coordinates, and then we would subtract their absolute values. 8 minus 5 would give us that segment that is 3 long. So we can write these coordinates in for question 2, 8, 5 and 8, 8. Number 3, identify the ordered pairs of the endpoints of a horizontal line segment with a length of 6 units. So horizontal meaning going left to right, and it should be 6 units long. So this time, horizontal. Let's go across. We have 1, 2, 3, 4, 5, 6. This time I'm putting it into different quadrants, the endpoints. So it is 6 units long and it is horizontal. Now we need the endpoints. So we start at the origin. We went left 1, 2, 3, 4. And now we're here, and then we needed to go down 1, 2, 3. Left and down are both represented by negative values. To get to the other endpoint, we went right 2 and then down 3. In the previous lesson, we discussed how we look at the endpoints or the coordinate pieces that don't match. And since they're in different quadrants, we add their absolute values. The absolute value of negative 4 is 4. The absolute value of 2 is 2. And 4 plus 2 gives us that 6 for our length of the segment. Problem 4. A horizontal or vertical line segment with a length of 4 units has one endpoint at 1, 2. Identify the ordered pair of a point that could be the other endpoint of the line segment. So we can go horizontal or vertical from the endpoint 1, 2. If we go to the point 1, 2, that's 1 to the right and 2 up. It said 4 units long, and it could go horizontal or vertical. If we go 4 horizontal to the right, that would put us here. So that's one possible endpoint, which is 1, 2, 3, 4, 5, and then up 2. But we could also go from this pink point to the left to make a horizontal line segment that has its sides of 4 units. 1, 2, 3, 4. That would give us the coordinates 1, 2, 3 to the left, and then up 2. Another possibility is to go vertically 4. 1, 2, 3, 4. That has endpoints 1 to the right, and then 1, 2, 3, 4, 5, 6 up. And even one more possibility, we could go vertical down 1, 2, 3, 4. That has the endpoints 1 to the right and down 1, 2. So there are 4 different possibilities for question 4 or problem 4. Consider the point negative 2.5. Identify the ordered pair that is the reflection of the point across the y-axis. Plot both on the coordinate plane, then draw the line segment that connects the 2 points. So we start here, we're going to go -1, -2 and a half, and then up 4. If it's reflected across the y-axis, it's going to put it over here into quadrant 1. So we need to go 2 and a half on the other side of the y-axis. Then connect them. What is the length of the line segment you drew in part A? So we can count the whole sections. 1, 2, 3, 4. Here I have a half and a half, which make a whole. So 1, 2, 3, 4, 5. What is the line of symmetry of the line segment you drew in part A? The line of symmetry is where it splits it into 2 same pieces. So that would be the y-axis is the line of symmetry. You can see it's 2 and a half to the right and 2 and a half to the left. What do you notice about the x and y coordinates of the endpoints of the segment you drew in part A? Well, we have -2 and a half, 4, and this one over here, this endpoint, is +2 and a half, +4. So they have the same y coordinate, and their x coordinates are opposite. A line segment in quadrants 1 and 4 has a length of 6 units and is symmetric about the x-axis. Identify the ordered pair of one possible pair of endpoints, then another possible pair of endpoints, and state what they have in common. Let's go back to that page. Here's page 215. We are going to be in quadrant 1 and quadrant 4, and it was 6 units symmetric over the x-axis. So if it's 6 units, it needs to be split. So we would have 3 units going above and 3 units going below so that it was symmetric. Then we need to list out the endpoints. This is 1, 2, 3, 4, 5, 6, 7, 8 to the right and 3 up. Then 8 to the right and 3 down. Another possibility is to be closer to that axis, but again it needs to be 3 above so that it's symmetric, and 3 below. This would be 2 to the right and 3 up, and 2 to the right and 3 down. So what do these endpoints have in common? The y-coordinates were 3 and -3, and the reason is if it's 6 units and symmetric, evenly into 2 parts, would give us 3 above that x-axis and 3 below. The graph shows 2 vertices of a rectangle. What are the ordered pair of the other 2 vertices? So we can't just connect these two, because then that would make a triangle, we would need to extend this going towards the other point, and this one going towards the other point, and then this one going towards it, and this one going towards it. So you can see that it's going to create a rectangle. What are the ordered pairs of the other two vertices? So this one we went 2 to the left and 3 up. And for this one we went 2 to the right and 3 down. Write the ordered pair of the 4 vertices and an additional point from each side of the rectangle. Well, we know those two that we just wrote down are in there. This one that was originally there is 2 right and 3 up. Those are both positive values. This one is 2 left and 3 down. Those are both negative values. And then we need another point on each side. So I have 2 right and 1 up. I have 0 right or left and 3 up. This is 2 to the left and 1 down. This one is 1 to the right and 3 down. Identify a pattern in the ordered pairs you wrote in Part B. Well, there are 3 of them with the x-coordinate that match. There are also 3 of them with y-coordinates that match. So these extra points on the sides that we drew either matches the x-coordinate or the y-coordinate from the other vertices. Again, those vertices are just fancy ways of saying the corners of the rectangle. Two vertices of a rectangle are located at 1, 6 and -8. 1, -6 and -8, -6. Then it says, suppose the rectangle has a perimeter of 26 units. What could be the ordered pairs of the other two vertices? Draw your rectangle in the coordinate plane. So for the perimeter, that is all 4 sides added together. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a distance of 9. Now, something that we know about rectangles is if one side is 9, another side has to be 9. So if the total is 26, and I already have 2 sides that are 9, how much does that leave me with? Well, that leaves us with 8. But that doesn't mean each of these sides are 8, because then that would be 8 plus 9 is 17, plus 8 would make 25, plus 9 would make 34, not 26. So instead, we need to split that 8 up onto those two sides. 8 split into two parts would be 4. So then 4 plus 9 is 13, plus 4 is 17, plus 9 makes 26. So we could either go up by making this line segment the bottom of our rectangle, or we could go down and making it the top of our rectangle. We just need to select one possibility. So I'm going to make this the bottom. I need the side to be 4, and this side to be 4, and then the top piece remains 9. So now we need to label those vertices and their coordinates. This went 1 to the right, and then down 2, and this one went 8 to the left, and down 2. Consider the points 4, 5, and 4, negative 3.5. Plot and label the points in the coordinate plane. Draw the line segment that connects the 2 points. So 4 to the right and 5 up, and then 4 to the right and 3.5 down. 1, 2, 3 and a half. Then draw the segment that connects them. Draw a horizontal line segment starting at 4, negative 3.5, and has a length of 6 units. So we're starting at this bottom point, and we're going 6 units. So this is 1, 2, 3, 4, 5, 6. And label the endpoint. Well, that is 2 to the left, so negative 2, and then down 1, 2, 3.5. The 2 line segments you drew in parts A and B can be considered the sides of a rectangle. Locate and label the 4th vertex of your rectangle. Draw the 2 remaining line segments to create the rectangle. So again, if we continue this one going out towards the left, and this one continuing up, you can see that those line segments cross at what would be the 4th vertex. So that was 2 to the left, and then 1, 2, 3, 4, 5 up. And we can adjust these line segments so they're not continuing past the vertex, but just right up to it. Now, this isn't the only possibility. We could have also created our rectangle going out the opposite direction, 6, and created a rectangle out this way. So if you have an alternative answer, that's okay. There are 2 possibilities for this problem. What are the lengths and widths of your rectangle? Well, we had a length of 6. It told us that there. And this was 1, 2, 3, 4, 5, 6, 7, 8, and a half. What is the perimeter of your rectangle? So for perimeter, we would need the 6 and the 8.5 for the first two sides, and then we need the last two sides, as we add up all the sides around it. Well, 6 plus 8.5, 6 plus 8 would give us 14, and that extra half. 6 and 8.5 would give us another 14.5. And then if we combine those, 14 and 14 make 28. A half and a half make a whole, so that would give us 29 units. For area, we multiply those values together. Base times the height, or the length times the width. I prefer to do this as an improper fraction. 8 times 2 is 16, plus 1 more is 17. There's an invisible 1 down here. We can also simplify as we go. 2 fits into 2 once. 2 fits into 6 3 times. 1 times 1 on the bottom gives us 1. And 3 sets of 17. Well, 3 sets of 10 would be 30. And 3 sets of 7 would be 21. So that would give us 51 over 1, which is just 51. And it's units squared, or square units. Make sure your lesson is filled in your workbook and in your composition book. Check back for lesson 17 coming shortly.